Gaining access to the eye of the storm and all the secrets that lie there was thought impossible for most of our history. But as vehicle engineering advanced, with ever stronger trucks and vans taking to the roads, it wasn't too long before people started having the idea of modifying them with specialist equipment to head straight for the eye of the storm in the name of science. But what data do they actually capture? How important are their discoveries? Is this all real science or just entertainment? And how far can these modified storm-chasing trucks go? In 1956, a man named David Hoadley, who is widely considered to be the godfather of storm chasing, began chasing and observing storms from the seat of his Chevrolet Bel Air. Without access to any high-tech equipment, David relied on a cautious and informed approach to his chases that would become vital for a small but growing storm-chasing community. He would scour the AM radio forecasts, monitoring movements from afar with binoculars and still and film cameras to capture the phenomena from as safe a distance as possible. Although he did carry a simple barometer on board to measure changes in atmospheric pressure, and on later expeditions he added an anemometer to understand wind speed. It was his intuition and experience that laid the ground for storm chasers and their vehicles that were to follow. David's legacy included the creation of Storm Track magazine that ran from 1977 to 2002, influencing entire new generations with tips, stories, and equipment reviews to share that would push the field of storm-chasing vehicles through the next 2 decades into the 21st century with incredible force. The 1970s saw the National Swerve Storms Laboratory modify their own trucks and vans with meteorological equipment to chase these events on a bigger scale in a mobile way for the first time. Landmark breakthroughs then continued. Meteorologist Neil Ward is credited with advancing vehicle design through his work in the famous Tornado Alley of Oklahoma, Texas, Kansas, and the surrounding states, adding thermometers and hygrometers to the vehicle's resources for better understanding on temperature differences and humidity. The 1990s ushered in a new era as the available weather tools and instruments became more sophisticated. It was only a matter of time before the tech was combined with the vehicles.
We want to understand the differences between thunderstorms that produce tornadoes and the ones that don't. The ones that produce short-lived tornadoes and the ones that produce long-lived tornadoes. If we can understand those differences, then we can guide forecasters to help them make better forecasts.
Dr. Joshua Wurman, an innovative doctor of meteorology from the Massachusetts Institute of Technology, created his Doppler on wheels, a fleet of mobile radar units mounted on trucks to react and be rapidly deployed towards hurricanes, tornadoes, and storms, gathering new data on precipitation, wind speeds, and storm structure through dual polarization radar that successfully differentiates between rail, hail, or snow, and rapid scanning that made real-time atmospheric data available for the first time. This revolutionized the area of storm chasing, and the vehicle engineering projects that were just around the corner would make full use of it in a big way. It was now clear that it wasn't just the storms that people were chasing. It was the developments in tech, in science, and in public safety that came along for the ride. As is often the case with exciting and burgeoning scientific scenes, popular culture was beginning to take notice too. The 1996 movie Twister, starring Bill Paxton, tells the story of storm chasers in modified vehicles, displaying all of the action, drama, and thrills that accompany the pursuit of severe weather. It captured the public's attention and brought the study to the widest audience possible, with the advent of the internet and streaming sites not long after the stage was set for some of the biggest and best storm-chasing trucks, tanks, and modified vehicles to appear. The filmmaker Sean Casey upped the ante dramatically with the Tornado Intercept Vehicle in 2003. His work on the Discovery Channel's Storm Chasers drove him to take a 1997 Ford F450 to the very limits of modification. His goal was to equip it with a state-of-the-art IMAX camera that would allow him to obtain stunning footage in high definition at incredibly close proximity, right at the heart of some of the most severe tornadoes on the planet. The TIV has a steel armor plating of up to 1 inch thick in key areas of the truck, with bulletproof glass of 1.63 inches to protect Sean and his crew from the elemental debris they encountered. The hydraulic system was installed to lower the chassis, reduce wind effects, and increase overall stability when filming or capturing data. And a steel turret on the top houses a hefty IMAX camera that can film in full 360-degree motion. This meant the truck was now weighing in at a massive 6,350 kilos, all at a cost of around $400,000. That makes it one hell of a rainy day fund. The TIV was eventually upgraded in 2007 using a Dodge Ram 3500 chassis. This time, the fundamentals were the same, with improved suspension, better aerodynamics, and a Stringer engine, meaning the new TIV2 storm-chasing beast now weighed almost 7,500 kilograms, but could reach speeds of 100 miles per hour when called upon. It would be fair to say that the TIV was brought to life with a primary interest in obtaining footage and a more secondary aim of providing data for storm research. Reed Timmer, an Oklahoma meteorology master and also a contributor to the Storm Chaser series, wanted to go even further with his Dominator series of storm-chasing trucks. He realized that so much of the research and insight from storm event activity would be performed in labs far from the storm itself, so he wanted to see how far he could go in making a vehicle that was a scientific storm lab on wheels, ready to race into action, collecting and analyzing data in real time. The Dominator 3 is his amazing response to all these challenges. Introduced in 2013, it's based on a Ford F340 Super Duty with a 6.7-liter turbo diesel power stroke engine and 3/4-inch heavy-duty steel and polycarbonate armor to protect it from the flying debris that spirals around the truck in winds that have been recorded reaching a staggering 321 miles per hour. Even a pebble can move at over 150 miles per hour, so the thick bulletproof glass of over 1.5 inches thick is an absolute must. At over 4,500 kilos, the Dominator 3 can hit 70 miles per hour easily, with an armored peak on the dashboard funneling the wind for superior aerodynamics, to stay agile and responsive to the conditions it works in. But when it does find itself in the eye of the storm, it needs stability. Serious stability. In order to stop the rushing winds flying under the Dominator and turning everything on its head. A hydraulic system brings it flush to the ground with 8-inch spikes that are deployed to drive into the earth as anchors to fix it in place. The same air compression system opens and closes 2 massive 360-kilo gull-wing doors that also act as protection from threats above. If the crew needs to jump out and observe rapidly changing weather situations, they wouldn't want to be at the mercy of the hail core of a tornado with baseball-sized hailstones flashing around their heads. The Dominator 3 has 2 important functions that determine the instruments and tech it uses. Research is conducted with the vehicle as a tornado interceptor, taking ground-level measurements, meaning the whole truck becomes a measuring probe for the storm activity, and that is an intense process, putting the Dominator 3 and its crew where very few people have been before and survived to tell the tale. The truck is fitted out with high-resolution anemometers for wind speed and direction. These capture any sudden changes in wind speed or direction live in the chase. Barometers monitor pressure drops, look for the arrival and the intensity of a tornado through these indicators. Thermometers and hygrometers measure air temperature and humidity to better understand the thermodynamic structure of the tornado. Rain gauges measure rainfall and determine whether the precipitation is hail or rain to act as a parameter of severity, and dew point sensors measure moisture level in the atmosphere to assess storm formation and development. The onboard computers log all this data for real-time analysis on board, whilst also transmitting it to data labs and other research facilities for the inevitable post-storm post-mortem. The applications of this data have interesting and wide-ranging effects, improving weather models for much more accurate severe weather warnings that can be relayed faster, aiding scientific research into the construction, behavior, and patterns of storms. And, importantly, the Dominator 3 and storm-chasing trucks like it can greatly elevate public safety with live broadcasts and data helping to prevent damage to property and ultimately save lives. The ground-level work carried out by Dominator 3 and other storm-chasing trucks is now a recognized addition to the science methods of meteorologists all over the world. But the new goal of the Dominator 3 and the second major function is get closer than ever before at the eye of the storm, off the ground, and into the heart of a tornado itself to take measurements that will catapult storm chasers into a new level of understanding entirely. The only problem is, getting there is so difficult that it has only been achieved once. The challenge comes from the structure of a tornado, with a wall of powerful sinking air acting as protection and preventing probes, cameras, or measuring instruments from entering. The Dominator 3 needed a way to blast through this protection, and what better way than arming the truck with a fully deployable rocket? The onboard rocket launcher comes in two parts: the carrier and the Dominator Skyfall sensor that sits on the rocket's nose cone. The aim here, under intense pressure, is to get the rocket directly into the inflow notch of the Tornado supercell, while is swirls previously above the Dominator 3. As the rocket is deployed through a hand-operated ignition, a blast plate on board the truck allows for optimum propulsion, and stabilizing rods are employed to establish the necessary flight path early on. The rocket pierces the wall of sinking air, spinning around the vortex, and when inside, the nose cone releases, with a parachute deployed to carry the Skyfall sensor around inside the vortex at the very center of an active and massively powerful tornado. Live data is then available immediately, recording pressure, relative humidity, inertial measurement unit acceleration, and the physical information from the sensor as it oscillates wildly in the wind. Then another chase begins, as the high-resolution data needs to be recovered from the probe. The crew relies on the storm-chasing community, posting pictures online and following the tornado path until the Skyfall sensor eventually falls and is found in safe hands. The Dominator 3 must then get on the road to find it, and this can be quite a journey for that little instrument.
We're good.
When the Dominator crew were chasing an EF4 rated tornado that spun from Lawrence to Linfield in Kansas in May 2019, the rocket was successfully deployed and was found over 26 miles from launch, reaching heights of over 30,000 feet on a groundbreaking ride for both storm chasing and science. For Reed Timmer, Sean Casey, and countless other crews across the globe, their pursuit provides a unique experience that combines the perfect storm of science, thrill-seeking, and entertainment, producing fantastic, pioneering, and impressive results for every element. It will be very interesting to see what the forecast is for all of their future endeavors.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.